Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss about Intel 8086 microprocessor. Released by Intel in the year 1976, Intel 8086 microprocessor is an enhanced version of Intel 8085 microprocessor. Intel 8086 microprocessor, in contrast to Intel 8085 microprocessor, is a 16-bit microprocessor, which implies that Intel 8086 microprocessor is capable of processing 16-bit of data per unit time. Intel 8086 microprocessor has 20 address lines and 16 data lines, which implies Intel 8086 microprocessor is capable of addressing up to 2 to the power 20 address location, which is equals to 1048576 address locations, which can be approximated to 1 megabyte of memory. This further implies that the total addressable space of Intel 8086 microprocessor ranges from 00000H to FFFFH, wherein the entire memory is organized into segments of 64 kilobyte size. Here, segment basically refers to logical partitioning of the memory in order to facilitate and speed up operations. From here, we can understand that in case of Intel 8086 microprocessor, the size of the address will be of 20 bits. As we have learned that the total addressable space of Intel 8086 microprocessor is 1 megabyte, this facilitates for performing multi-programming. Like in case of Intel 8085 microprocessor, Intel 8086 microprocessor has multiplex address data lines. This is performed in order to reduce the total number of pins in the pin configuration of 8086 microprocessor. One of the notable features of Intel 8086 microprocessor is that Intel 8086 microprocessor operates in two different modes, namely multiprocessor mode and uniprocessor mode. Multiprocessor mode is also referred to as maximum mode, whereas uniprocessor mode is also referred to as minimum mode. In multiprocessor mode or maximum mode, Intel 8086 microprocessor works in harmony with other co-processors like 8087, 8089 in order to perform purpose-specific operations. This is performed in order to enhance multiprocessing capability of Intel 8086 microprocessor. Some of the other features of Intel 8086 microprocessor includes 8086 microprocessor operates with 5 volt power supply and single phase clock frequency. It has 14 CPU hardware registers which are of 16-bit length. It has 40 pins in the pin configurations with around 29,000 transistors. And 8086 microprocessor implements pipelining in order to increase instruction throughput. So these are some of the notable features or essence of Intel 8086 microprocessor. Now let us try to elaborate more on the features of 8086 microprocessor. Intel 8086 microprocessor was the first 16-bit microprocessor with 16-bit ALU, 16-bit registers, 16-bit internal bus and 16-bit external data bus in order to facilitate faster processing. Based on frequency, there are three versions in which 8086 microprocessors are available. 8086 microprocessor that operates at 5 MHz, 8086 microprocessor that operates on 8 MHz, and 8086 microprocessor that operates on 10 MHz. As discussed before, Intel 8086 microprocessor has 14 16-bit hardware registers. These 14 16-bit hardware registers are categorized into 5 notable categories. These categories are namely 4 general purpose registers, 4 segment registers, 4 pointer and index registers, 1 instruction pointer, and 1 flag register. Again, I'll repeat it. There are 4 general purpose registers. There are 4 segment registers. There are 4 pointer and index registers. There is 1 instruction pointer and there is 1 flag register. Now, let us discuss these categories in greater detail. The 4 general purpose registers include AX, BX, CX and DX. Here X stands for 16-bit and in case of AX, A stands for accumulator. Accumulator is used as default operand in multiplication and division instructions. It is also used for I/O related operations. BX or base register is used as a pointer to a memory location where data is stored. It can also be used for accessing elements from an array. CX or count register, it is used in order to hold count value while performing loop operations or while executing loops in a programming construct. Loop and repeat operations in 8086 uses CX as the default operand. DX or data register is used as default operand in multiplication and division instruction. It also acts as the I/O address pointer in case of in and out instruction. Now let us move on to the segment registers. There are 4 segment registers, namely DS, CS, ES and SS, which stands for data segment register, code segment register, extra segment register and stack segment register, respectively. Now let us first try to understand what is segment and what is memory segmentation. Segment is a logical partitioning of the memory in order to facilitate and speed up performance of an operation. So segment is logical portioning of the memory in order to facilitate faster execution. Likewise, memory segmentation is the process in which the main memory of the computer is logically divided into different segments and each segment has its own base address. Now, the purpose of these 4 segment registers, that are DS, CS, ES and SS, is to store the base address of the logical segment that belongs to a particular program. Again, I'll repeat it. The purpose of these segment registers are to store the base address of the segments belonging to a program. This is basically used in order to enhance the speed of execution of computer systems so that the processor is able to fetch and execute the data from the memory easily and at a faster rate. The bus interface unit consists of four 16-bit special purpose registers called as segment registers. To start with, the code segment register or CS. Code segment register or CS is used for addressing memory location in the code segment of the memory where the executable program is stored. So with the help of a certain offset value, we can access the bytes pertaining to the code using the code segment register. Now likewise, we have data segment register. It points to the data segment of the memory where the data is stored. Stack segment register SS is used for addressing stack segment of the memory. The stack segment is that segment of the memory which is used to store stack data. Extra segment register, which is also referred to as ES, is used as some of the memory in order to store data. So here we have four segment registers, namely CS, DS, SS, ES, which is used in order to point to code segment, data segment, stack segment, and extra segment respectively. So as we have learned in the previous slide that in case of 8086, the memory is partitioned into segments of 64 kilobyte. So here each of these segment registers will point to 64 kilobyte of memory space, which implies that a program in case of 8086 microprocessor can access up to only 64 into 4, that is 256 kilobyte of memory space. So every program in case of 8086 microprocessor is allocated 256 kilobytes of memory space because we have four segments in each program where the size of each segment is 64 kilobyte. So this implies 8086 does not work with the whole 1 megabyte of memory at any given point of time, but works with 464 kilobyte segments within the whole 1 megabyte of memory. Now, as I've said that the segment registers are capable of pointing to the base address of the segment, and with use of certain offset value, we can create displacement and access specific byte locations in the respective segments. So in conjunction with the code segment register, we have the offset as instruction pointer or IP. In conjunction with DS data segment register, we have offset as BX, DI and SI. So we have base register, we have destination index and source index as offset being used with DS. Along with SS, we use offset as SP and BP. And eventually with ES, we use offset as BX, DI and SI. So again, I'll repeat it. Offset is displacement that you create from the base address of the segment that is being held by either of CS, DS, SS and ES. Now let us try to understand what are the advantages of segmentation. Now segmentation primarily allows for placing data, code and stack related information pertaining to the program in the respective segments, which are data segment, code segment and stack segment, which facilitates easy access and ease of operation. It allows to extend the address ability of the processor. That is, segmentation allows the use of 16-bit registers to give an addressing capability of 1 megabyte. Without segmentation, it would require 20-bit register, which is not possible in case of 8086 microprocessor. Now let us try to understand this with the help of a very simple example. So here we need to create a 20-bit physical address representation of an instruction using the content of code segment and instruction pointer. So as I've said that code segment register stores the base address of the code segment, and IP is used as an offset or displacement with correlation with the code segment register. So here, in order to calculate physical address, so first what we do is we left shift the content of CS by 4 bits, and then we add the content of IP. So uh, we multiply the content of CS by 16 and then add the content of IP. So here let us consider the value of CF is F000S. So CS has F000H and IP has 2010H. So first what we do is we shift the content of CS by 4 times, right? So what we do is we multiply it by 16, so it will be F quadruple 0, and then we add the content of IP, that is 2010H. So once we add the content of IP, the physical address will be computed as F2010H. So here we have a 20-bit address representation created from 16-bit code segment register and the instruction pointer. So this is the way how we create a representation for the physical address. So it is possible to enhance the memory size of code data or stack segment beyond 64 kilobytes by allotting more than one segment for each area. So this can also this is also one of the advantage of segmentation. So now let us move on to the pointer and index registers. So there are 4 pointer and index registers. So the pointers are BP, SP, that is base pointer and stack pointer, and we have index registers SI and DI. SI stands for source index and DI stands for destination index. Now let us try to understand the utility of SP, BP, SI and DI. SP register, it points to the program stack and is used in conjunction with SS for accessing the stack segment. So this is already what we have learned. So it points to the program stack and is used in conjunction with SS in order to access the stack segment. Likewise, BP, it points to the data in the stack segment. Unlike SP, we can use BP to access data in other segments as well. Now source index register SI, so it points to the memory location in the data segment addressed by DS. So here SI is used in conjunction with the data segment register DS. By incrementing the content of SI, what we can do is we can access consecutive memory locations. This implies SI can be used in order to access an array. DI register, this register performs the same operation as that of SI. This register is used for performing string related operation, where DI is used in order to access the memory location addressed by ES. So it's capable of performing operations similar to that of SI, but very often it is used in order to perform a string related operation where you access data from the extra segment. Now let us try to understand instruction pointer register. Instruction pointer is a 16-bit register used in order to hold the address of the next instruction that is to be executed by the microprocessor. So as we have learned, IP is used in conjunction with the code segment register. So what we do is we use IP in order to calculate the physical address by using the code segment register of the instruction that is to be executed. Now let us move on to the flag register. 8086 has a 16-bit status register, which is also called as flag register or program status word. Out of 16 bits, 9 bits are active and 7 bits are left unused. Out of this 9 bits that are active, some are used in order to refer to status of the operation, and some are used in order to refer to the control signals. So the 9 active bits of the flag registers are portioned into status flags and control flags. Status flag reflects the result of operations executed by the processor, whereas control flag enables or disables certain operations of the microprocessor. Now let us try to understand these flags in greater detail. So here this is a pictorial representation of the flag register where the red marks the status flags or conditional flags and black marks the control flags. So we have 6 conditional flags. These flags are overflow flag, sign flag, zero flag, auxiliary flag, parity flag and carry flag. Whereas we have 3 control flags. These are directional flag, interrupt flag and trap flag. Now let's try to learn these flags in greater detail. The conditional flags are also referred to as OF, overflow flag, SF, sign flag, ZF, zero flag, AC, auxiliary carry flag, PF, parity flag and CF is carry flag. And we have 3 control flags. These are directional flag, DF, interrupt flag, IF and trap flag, TF. Now let us try to understand each of these flags. Now carry flag CF is set if there is carry in case of addition and borrow in case of subtraction. So it is set to 1 if there is carry in case of addition and borrow in case of subtraction. Parity flag PF is set to 1 if there are even number of ones in the lower order 8 bits of the result. Again, I'll repeat it. It is set to 1 if there are even number of ones in the lower order 8 bits of the result. Auxiliary carry. Auxiliary carry flag is set if there is a carry from third bit or borrow from third bit of the result. So if there is carry from third bit or borrow from third bit in case of addition and subtraction, auxiliary carry flag is set. Zero flag. Zero flag is set if the result of the arithmetic operation is 0. Sign flag is set if the most significant bit of the result is 1. Overflow flag. Overflow flag is set if there is a carry generated from 7th or 15th bit of assigned number during addition or borrow while performing subtraction operation. So if there's a carry from 7th or 15th bit or borrow from 7th or 15th bit during addition or subtraction operation in case of signed number arithmetic, then overflow flag is set. Now likewise, let us move on to the control flag. If trap flag is set, a trap is executed after each instruction. If trap flag is set, then a trap is executed after each instruction. CPU will reset the flag while transferring control to the interrupt handler. Likewise, interrupt flag. If interrupt flag is set, then a maskable interrupt type is recognized by the CPU, otherwise the interrupts are masked. If the IF is set and a maskable interrupt type is recognized by the CPU, then the CPU will reset the flag while transferring control to the interrupt handler. Likewise, direction flag. Direction flag is used for manipulation of data array in string instruction. If this particular flag is set, or if this particular flag is reset, the string is processed from lower address to higher order address. If the flag is set, the string is processed from higher order address towards lower order address. So depending upon whether the direction flag is set or reset, we move in the opposite direction. It increments or decrements indexed register based on the status of the direction flag. So these are the description of the various flags. So in this class, what we have learned about is we have learned about what 8086 microprocessor is all about, what are the features of 8086 microprocessor. We have discussed in brief the various modes of operation of 8086 microprocessor. Then we have come across some of the notable characteristics of 8086 microprocessor. Then we have learned about some of the notable features of 8086 microprocessor, where we have learned about uh, the different the description of the ALU, the size of the registers, the size of the internal and the external data bus. We have also learned about the various versions of 8086 microprocessor. We have learned about the various categories of hardware registers. We have learned about general purpose register. We have learned about segment register. We have learned about instruction pointer. We have learned about pointer and index register. We have learned about various flag registers. So in the next class, we will continue with the features of 8086 microprocessor. Till then, thank you and good evening.